Hi, I'm Isabel. Welcome back to the PAL YouTube channel. In this video we're going to cover activation functions and especially the most important ones, most popular ones used in machine learning. The four we're going to have a look at are sigmoid, then ReLU, also called rectified linear unit, but just call it ReLU, tanh, and then lastly softmax. Just a note, if you're not familiar with neural networks yet, please refer to one of our previous YouTube videos. So why do we use activation functions in machine learning? They are really essential because they introduce a nonlinearity into our network. This allows the network to learn complex patterns in the data, and without that, our neural network, regardless of its depth, would just act as a linear function. Okay, cool, let's get started with the sigmoid function. Sigmoid squashes its inputs into a range from 0 to 1, making it great for models that need to output probabilities. The equation is 1 over 1 plus e to the negative x. Sigmoid is still used today, but mostly in output layers for tasks such as binary classification. So for example, brain tumor, like simple brain tumor segmentation, does this pixel belong to the tumor class or not? It is not widely used anymore in the hidden layers due to the vanishing gradient problem. When we talk about the vanishing gradient problem, we mean when the gradients become very small when they're back propagated through the layers, leading to slower or stalled learning. We go over this in more depth in our backpropagation video. Okay, next we'll have a look at the ReLU activation function. ReLU is still really popular today, and it's mainly used for the hidden layers of a neural network, mainly because it's fast, it's very simple, and it avoids the vanishing gradient issue we talked about earlier with the sigmoid function. And ReLU is defined as the maximum between x and 0, and what that basically means is that when we have a negative input, it becomes 0, and if our input is positive, it stays as it is. Then we have the tanh function. It's similar to sigmoid, which you might remember squashes its input into the range from 0 to 1. Tanh on the other side has a slightly larger output range and goes from -1 to 1. You can see the equation on the screen somewhere now. This output range helps center the data around 0, which can make it easier for the next layer to learn and can lead to faster training convergence. Okay, and finally let's talk about the softmax activation function. Similar to sigmoid, it's also mainly used in the output layer of a network, and it's used for multi-class classification problems. It converts a vector of raw values, also called logits, into a probability distribution. What this means is that each output becomes a probability between 0 and 1, and the sum of all probabilities equals to 1. You may recognize this from common explanations of next token predictors, where the machine will give each word a probability and based on that probability pick the next word. In summary, activation functions like sigmoid, tanh, ReLU and softmax are essential for deep learning models to learn and represent complex data. They each have unique properties and purposes, so choosing the right one depends on the tasks you're working on. Thank you for watching. I hope you enjoyed the video and see you in the next one.